Hey everyone, and welcome. Today, we are diving into one of the biggest, most fundamental rules in all of science. Seriously, it dictates everything from why your coffee gets cold to the ultimate fate of the stars. We're talking about the second law of thermodynamics, what I like to call the universe's ultimate one-way street.
But let's bring it down to earth for a second. Just think about this for a moment. You can take a perfect, neatly organized egg, you crack it, and you whisk it into a complete mess. Easy. But have you ever seen a scrambled egg just reassemble itself, spontaneously pop back into a perfect yolk and white? No way. But why is that?
Well, the answer to that scrambled egg mystery, it comes down to this one incredible, universal rule. It's the key that unlocks not just breakfast table puzzles, but some of the biggest questions about the entire cosmos.
All right, so to really get this, we've got to look at the official rule. Now, I'll warn you, it sounds a little dense, a little technical at first. But just stick with me here, because we're going to tear it apart and see what makes it tick.
Okay, here it is, straight from the source. The total entropy of an isolated system never decreases. It either increases or remains constant. Right, so two words we need to flag there, entropy and isolated system. Just hang on to those for a minute, we're going to need them.
So what on earth does that sentence actually mean? Let's translate that from science speak into plain English. Let's figure out what it's really saying.
Turns out, this law has two massive consequences for, well, pretty much everything. First, it means that things in nature happen in a specific direction. It gives us the arrow of time. Eggs scramble, ice melts in your drink, your room gets messy if you leave it alone, it always goes one way. And second, it tells us that you can't get a free lunch. Whenever you convert energy, like the gas in your car, to motion, you always lose some of it as useless waste heat. A perfect, 100% efficient engine, it's impossible.
Okay, now for that big word, entropy. What is it? You know, the easiest way to think about it is just as a measure of disorder, or randomness. So, imagine a brand new, perfectly ordered deck of cards. That has very low entropy. Now, give it a good shuffle. You've just massively increased its entropy. And as it turns out, the universe, it loves a shuffled deck.
And this is where it gets really interesting. Because this universal preference for messiness, for disorder, well, it draws a hard line in the sand. It clearly separates what can happen in our universe from what is just completely impossible.
So let's look at what the law says is possible. On one hand, you have entropy increasing. This is the default setting for pretty much everything. It's your hot coffee cooling down as its heat spreads out into the room. Disorder just naturally takes over. Then you have this other possibility, entropy remaining constant. But, and this is a huge but, this is a purely theoretical idea. It would need a perfect process, like a piston moving with absolutely zero friction, which, doesn't exist in the real world.
And that brings us to the big one. The one thing that the law says is absolutely, positively, 100% forbidden in an isolated system, which is just a fancy way of saying anything left on its own without energy pouring in from the outside. And the impossible outcome? For the total disorder to go down.
So, why? Why is a decrease in entropy impossible? Well, because that would mean things could just spontaneously organize themselves. It would be like a shattered glass piecing itself back together, or heat deciding to flow from the cold air into your hot coffee, making it even hotter. It's a numbers game, really. There are just vastly more ways for things to be disordered than for them to be ordered. The universe is just playing the odds.
Okay, so let's tie this all together now. What's the big takeaway from all this? Why does this one law matter so much?
This flowchart here really tells the whole story beautifully. The second law is the ultimate why behind so much of our reality. As you can see, it explains why we can never have perfectly efficient engines, because some energy will always be lost to disorder. And it shows us why everything from a single egg to the entire cosmos is on a one-way trip from a state of order to a state of, well, more disorder. It really is the engine of all change and the director of time itself.